Yes, hello everyone. Welcome to the course Data Structures. This is Thulasi Chitra, Associate Professor, Department of CSIT, MLR Institute of Technology. And in this session, we are going to discuss about AVL trees and its operations. As we have discussed in the previous session, what is AVL tree and what are the different operations also, just we have seen the overlook of it. Now we will be discussing about mainly on insertion. Searching also have given you an example. It is similarly like the BST, right? How we are going to perform binary search tree search operation. In the similar way, we are going to search the element in the AVL tree also. We don't find much more difference, right? And then when you are going to see about insertion, here we need to concentrate much more on this, and a few points we have discussed in the previous session. Once you can look into that previous video so that you can understand this insertion operation very easily. Suppose you have given some elements. Here you can able to see these are the elements that was given. Now how you are going to perform the AVL tree construction? As we know, first thing, it has to follow the BST property, and the second one, whether the tree is balanced or not after every insertion. These two points you need to remember when you are going to perform this AVL tree insertion. Okay. First, I am going to insert 50. Yes, after inserting 50, check for the balance factor. It is 0. Why? Because you don't have the left and right subtrees. Because of that, tree is balanced. Now, I am going to insert 20. Check with root node. Yes, it is less than 50. So that I am going to insert 20 here. Now check the balance factor for this. This one is 0 because of leaf node. You don't have left and right subtrees. And for 50, it is 1 minus 0. The balance factor is 1. You don't have any problem if it is of 0, minus 1 and 1. Now insert 60. I am going to insert 60. Now where I need to insert 60, check with the root node. It is 50. 60 is greater than 50. So that we need to insert on the right side of the tree. Now check the balance factor for this. This is 0 and this is also 0. And this one is 1 minus 1 is nothing but 0. This is also balanced. Don't have any problem. Now insert 10. Now I am inserting 10 value. Observe. 10 value we need to insert. Check with 50. 10 is lesser than 50. So go to this side on the left subtree. 10 is lesser than 20. So we are going to insert on the left of 20. Right. After inserting, now check for the balance factor. For 10, it is 0. For 20, 1 minus 0 is nothing but 1. And this is 2. And here this is minus 1. So the balance factor is 1 only. So that the tree is balanced. We don't have any problem. Next, insert 8. Now where we need to insert this 8, check with 50 first. It is lesser than 50, go to 20. It is lesser than 20, go to 10. Again, it is smaller than 10. So, we need to insert 8 on left of 10. Now, you check for the balance factor for each and every node. For 8, it is 0. For 10, this is 1 minus 0, 1. And this is 2 minus 0. This is 2 and this is 3 minus 1, right? This is also 2. Now here itself it is imbalancing these 3 nodes. Because of inserting 8, the tree is imbalanced. So we need to start checking from the leaf node to the leaf node towards the root node. In between that itself you got here imbalance. Now which rotation we need to perform? Right, this is happening because of which insertion we are doing? LL. Because of LL rotation, LL insertion, it is imbalance. So that we need to perform which rotation? We need to perform RR rotation. We need to perform RR rotation. So let me show me the same thing here. Because of this, it is imbalanced. Now we need to perform RR rotation on these 3 nodes. The first imbalanced node is 20. Because of this, first which one is imbalancing, that one we need to verify. Don't go for the root node directly. Okay. Now, which rotation we need to do here? RR rotation. RR rotation, how we are going to do? This one, this side, that is clockwise we need to rotate. When I am rotating these nodes, it will be coming down like this. 20 will be the right of 10, it will be the left of 10, right? Like this it will be rotated. Now check for the balancing of tree. This is 0, this is 0 and this is also 0. This is 2 minus 1 is 1. Yes, now tree is balanced. Okay. Next, I want to insert 15. Where I need to insert 15? Check with 50 first. Less than 50. Check with the 10. Check with 10. Yes. 15 is greater than 10. So we need to move to the right side. Next, 20. 15 is less than 20. So we are going to insert here. Right. After inserting, now check for the balance factor. This is 0. This is 1. You don't have the right part. And this one is, you have this, here you have 1 minus 2 minus 1. You don't have any problem. Now check for this 1, 2 and 3. 3 minus 1 is nothing but 2. Right? You know the remaining will be 0. Leaf nodes will be 0. That's why I have not mentioned them. Right? 3 minus 1 equal to 2. Now, which of the 3 nodes I need to select for balancing the tree? I have inserted the node here. Where I am getting the imbalancing? Here. The imbalancing is at the root node. Right? Because of this, we need to select these 3 nodes. These 3 nodes as for balancing the tree. Let us see. The first imbalanced node on the path from the newly inserted node to 15 is the root node. We have verified, right? The first imbalanced node is 50. So that, now count the 3 nodes from the node 50 in the direction of leaf node. From here, I need to count. This is imbalancing, right? From there, you need to verify for the node which you have inserted is 15. From there, we need to check for the 3 nodes. These are the 3 nodes, right? That's why we need to perform the rotation now. What rotation we are going to do? Right, here we are going to get, because of LR, this is imbalanced. LR, this is imbalanced. That's why we need to perform this rotation. What rotation? We need to perform LR rotation. We need to perform. That means for R, on R, first we need to perform the left rotation, and on L we need to perform the right rotation. Okay, because of this. Now, when I am going to do this, first what is the tree I am going to get? 50, right? 50 first. Then on this we are going to perform the left rotation. So we are going to get 20, 10 and then 8, right? And for 20 you have 15 as the left element. For 20, you have already left element, right? 15 as the left element. So, for 20 already 10 is there. 10 is the left element. So that we can't insert 15 here. Where we need to insert this 15? I need to insert 15 to the right of 10. Why? Because 15 is greater than 10. So that it will be the right part of it. Now, after getting this, I need to perform again the right rotation. This is 60 we have. Now, perform the right rotation for this. What is the right rotation you are going to get? After performing right rotation, you are going to get a 20 here, 10 here, 50, and right of it is 60. And this one is 8 and 50. Right? Like this way, you are going to get the rotation. Now the tree is balanced. You can check the nodes. Here you have 2, 2. Yes, it is balanced. The tree is balanced. Now you have to remember this point. From where we need to select the 3 nodes to make the tree to be perform rotations, tree to perform rotations, right? Now insert 32. Yes, inserting 32. It is greater than 20, less than 50. So we are going to insert 32 on left of 50. You don't have any problem. Here tree is balanced. We can check the balance factor for each and every node. Next, insert 46. 46 is greater than 20. So go to right of it. 46 is less than 50. So go to left of it. 46 is greater than 32. So we are going to insert here. After inserting, check for the balance factor. This is 0, 0, 0, 0. Only for after inserting that only you can verify. No need to verify the remaining nodes. And this is minus 1. And this is 2 minus 1 is 1. And here you have 1, 2, 3. Here you have 2. 2 minus 3 is nothing but minus 1. Here also the tree is balanced. No need to go for any rotations. Next, insert 11. Where we need to insert 11? 11 should be inserted. Check with the root node. 11 is less than 20. Move to the left subtree. 11 is greater than 10. Move to the right subtree. 11 is lesser than 15. So we need to insert on the left part. Wherever you inserted, check with the balance factor. This is 0. This is 1. This is 1 minus 2 minus 1. And this is 1, 2, 3. 3 minus, this is also 3. 0. So here also it is balanced. No need to do any rotations. Now insert 48. Right. Now check for where we need to insert this 48. 48 is greater than 20. Go to the right of it. Right subtree. 48 is less than 50. So we need to move to the left subtree. 48 is greater than 32. Move to the right part of it. 48 is greater than 46. We need to insert here. Now after inserting, check the balance factor. No need to check for the left subtree. Where we have inserted, that part you verify enough. Right? This is 0. This is minus 1. This is minus 2. Right? Minus 2 is not possible. Right? Now, and for this you have 3. 1, 2, 3. 3 minus 1. This is 2. Right? But when you are checking the balance factor, now observe which of the elements we need to choose. Observe. The first imbalanced node from the path to the newly inserted one is to the root node. The first imbalancing node is at 32. Yes, we have seen here. Here itself we got the imbalance. So we are going to select those 3 nodes. Now count the 3 nodes from the 32 in the direction of leaf node. Here we are getting the imbalancing. From there you need to count the 3 nodes. These are the 3 nodes, right? Why it is imbalanced? Because of RR it is imbalanced. Which rotation we need to do? We need to perform the LL rotation. When I am going to perform LL rotation, just simply remember which is the median element among these 32, 46 and 48. Which is the middle element? 46 is the middle element. That should become the root node and this will be the left and this is the right. When you have any confusion after rotation which nodes will come, based on this you can place it, right? 46 will be the root node, 32 and 48 or left and right child for it. Now you can check the tree is balanced. Okay. Like this way, you can try with some more examples where you can perform the insertion, right? And I hope you understand this concept, but try the same example and perform the operations properly, that is rotations, so whether you could understand it properly. I have given some points also here, how you need to select that particular node which is imbalanced, how you need to select those 3 nodes to be selected, right? 3 nodes to be selected for performing the rotations also. If you could go through with these points and the example which I have been solved, so that you could understand very easily. Okay, let us see the summary what we have seen in this session. AVL tree insertion operation we have seen mainly. Then we have already discussed about searching and deletion. I said as based on BST we are going to perform the deletion. If possible, we will see one more example on deletion in the next session. Okay, and mainly concentrate on this insertion part. Take some elements, not only the same elements, we take some elements and try to construct an AVL tree and check the balance factor for each and every node. Okay, check balance factor for each and every node after insertion. If it is having the balance factor of -1, 0 or 1, you don't have any problem. Otherwise, we need to go for the rotations. That rotations also how we need to perform in each and every step we have discussed in the previous example, right? So, if you have any doubt, once again go through with the same example or same video and try to solve the same example first, so that you can get an idea to solve the other examples. Thank you.